You know, when you look at a massive ship, you think of the engines, the propellers, but there's a whole circulatory system inside that's just as vital. And at the heart of that system, pumps. They are the tireless workhorses that literally keep a ship alive and running efficiently out at sea. So in this explainer, we're going to dive into the different types of pumps that make it all happen. Yeah, take a look. These are the guys doing the heavy lifting behind the scenes. They're the constantly running heart of the vessel. Think about it. They're moving everything from seawater to cool the massive engines, to fuel oil, and even the cargo itself. Without these pumps, a ship is really just a big piece of floating steel, going nowhere.
So how do we even begin to categorize all these different types? Well, it's actually simpler than you might think. Just about every single pump you'll find on a ship belongs to one of two major families, and we're going to use these two families as a kind of roadmap for our tour today.
And here's that roadmap. Every pump fits into one of these two main categories, dynamic or positive displacement. And this isn't just a technicality. This difference is everything. It dictates exactly how a pump works and what job it's designed for. We're going to start our journey with the dynamic pumps, kind of the movers and shakers of the ship's fluid systems. Okay, so let's get into dynamic pumps. The key thing to remember here is energy and motion. These pumps don't trap fluid in a chamber. Instead, they add energy to it, using velocity and momentum to get the liquid moving from point A to point B. That's why I like to call them the movers.
Our first stop in the dynamic family is probably the most common type of pump you will ever find on a ship, the centrifugal radial flow pump.
This diagram here really shows the simple genius of it. Fluid gets sucked into the center, that's called the impeller eye, and then a spinning impeller just flings it outwards. It's a really simple but incredibly powerful design, which is what makes these pumps so common and so reliable. It's all about turning that spinning energy into fluid motion. And because they're so simple and tough, you find them everywhere. They're the absolute go-to for seawater cooling systems, which are essential for the engines. They power the main and emergency firefighting systems, they handle all sorts of general service duties, and they manage the ship's stability through ballast water operations. They are true all-purpose workhorses.
Now, building on that concept, what if you need more than just flow? What if you need some serious high pressure? Well, that's exactly where the multi-stage radial flow pump comes into play. It's basically a beefed-up, high-pressure version of the pump we just looked at.
Just think of it like a relay race for pressure. As the fluid goes through the first impeller, it gets a boost. Then it goes to the next one and gets another boost, and so on down the line. By the time that fluid comes out the other end, it's at an incredibly high pressure, ready to handle some of the toughest jobs on the ship. So where would you need that kind of intense pressure? The number one spot is in the ship's power plant, for the boiler feed water system. This pump has to be strong enough to literally force water into a boiler that's already filled with high-pressure steam. It's an incredibly demanding job, and this is the pump that's built for it. All right, now for the final member of our dynamic pump family, the axial flow pump. This one looks and acts totally different because, well, it's built for a totally different purpose. The best way to think about this is to imagine a big, powerful fan inside a pipe. That's pretty much how an axial flow pump works. See, it's not about flinging fluid outwards. It's all about pushing a massive volume of liquid straight through, parallel to the shaft. This design is perfect when you just need to move a huge amount of liquid very, very quickly. Its specialty is moving incredible volumes of liquid, but at a relatively low pressure. That makes it the perfect tool for one specific job, discharging cargo on big tankers. When you've got to move enormous quantities of something like crude oil fast, this is your pump. But it's not the right tool for the job if you're dealing with thicker, high-viscosity stuff. Okay, so before we switch over to the other side of the family, let's just quickly recap. The dynamic pumps we've seen all use velocity to create flow. They're great for high flow rates. This is a completely different idea from the other family, positive displacement pumps, which work by trapping a fixed amount of fluid and then pushing it out. And that brings us perfectly to our second major category. If the dynamic pumps are the movers, then you can think of positive displacement pumps as the pushers. Their whole method is different. They trap a very specific volume of fluid and then they physically force it or push it out the other side. And this family is really full of specialists. You've got your rotary pumps, which might use gears or screws that mesh together to move fluid with incredible precision. They give you a really smooth, constant flow. And then you have reciprocating pumps, which use pistons or plungers to create a really powerful suction and discharge stroke. These are the pumps you call on when you have to move thick, sludgy stuff, or when you need to deliver a very precise amount of liquid against some serious pressure.
You know, when you boil it all down, the main takeaway here is pretty simple. Different jobs need different tools. In marine engineering, you can't just grab any old pump for any task. The safety and the efficiency of the entire vessel depend on choosing exactly the right pump for the right purpose, whether that purpose is high volume, high pressure, or handling really thick fluids.
And that pretty much wraps up our overview. But hey, I'll leave you with a little something to think about. Based on everything we've just covered, which specific type of dynamic pump do you think would be absolutely essential for providing the huge volume of water needed for emergency firefighting on a big ship? Have a think about which one fits that job description perfectly.